Hi everybody, I'm Laurie, Head of Developer Relations at Arize AI. Now that you've learned all about Evals in theory, we thought it would be useful to demonstrate how they work in practice. To that end, we're going to be doing a series of 3 quick videos. The first will cover basic observability, capturing traces, inspecting them, and understanding what they mean. The second will take a set of traces and use them to create an actual evaluation, a test of whether the traces are good or bad. In the final one, we'll run experiments. We'll take some traces and create a data set, and then attempt to improve the performance of our app by measuring the success of whether our evaluations improve or not. So let's dive in. Here we've got a series of 3 simple Python files that are going to follow our 3 videos. In this first one, we are going to create a CrewAI agent and then run it to collect some traces into our Phoenix application. So you can see some basic boilerplate here. We're loading our end file, which contains a whole bunch of API keys, OpenAI for Arize Phoenix, and for Serper. Serper is a tool that we're going to use, that our agent is going to use to search the web to get additional information as part of its research. Once we've got the boilerplate out of the way, we go to the instrumentation itself. We're importing register from phoenix.otel, and all we do is these 2 lines of code. We import register, and then we call register with a project name and set auto instrument is equal to true. This works because the CrewAI framework is already fully instrumented and ready to work with Arize Phoenix. It is not the only framework that's true of. We support lots of frameworks, including LangChain, LangGraph, LlamaIndex, Nostra, Vercel AI, Haystack, and many more. But in this case, we're going to be doing a CrewAI agent, so I'm just going to do a super quick explanation of what CrewAI is doing here. CrewAI works by creating an agent out of a series of sub-agents, each of which have a task. So we are instantiating the Serper dev tool here, and then we're creating a financial research analyst agent with the goal of gathering up-to-date financial data and a very thin backstory. It's allowed to iterate at least twice, and it's allowed to use the search tool. We are creating a second agent here called the financial report writer, whose job is to take the research from the first agent and summarize the research into clear, actionable insights. We've given it max iterations of 2, and both of them it is allowed to delegate, which means that it's allowed to ask the other agent for research. The actual tasks that we're going to give to our agent are to do some research with a specific focus and to write a report based on the research. So these tasks match very closely to what it is that the agents are good at doing. And then in CrewAI, what you do is you take your agents and your tasks and you assemble them into a crew. So here we're giving it the agents, we're giving it the tasks, and we told it to be very Voss. Now we can assemble our input. We're saying that the tickers should be the Tesla app, the Tesla company, and the focus should be financial analysis and market outlook. Then we call result with crew kickoff. That is just how you run any CrewAI agent. We're not doing anything special, but because it's being instrumented at the top with Phoenix, it's going to automatically send traces to Phoenix. So let's go over to Phoenix and see what we've got. You can see in my Phoenix space, I have a bunch of traces, and one of them is called CrewAI Tracing Quick Start. Why is it called that? Because that is what we sent it as when we registered it. The act of sending traces with a specific project name is what creates that project inside of Phoenix. I've done all of the work of setting up my Phoenix space for you and also setting up my API keys. But if you were starting from scratch, you would just go to app.phoenix.arize.com and you would get your API key by generating one here. So let's look at CrewAI tracing. I've already run this, so there are a bunch of traces in here, but here's the one that we would have just run, which is the Tesla. You can see in the overall view that you can see whether or not traces ran successfully, what they're called, the input and output that they had, but you get the real, and you also get some summary data, like how many traces you got, how much the total LLM calls in your traces cost you, and the latency of those calls. If you click in, you get a lot more information. So you get the cost and latency. We'll talk about completeness in the second video. And you get a full graph of everything that your crew did. So you see that the crew was created. You see that the financial research analyst was executed. It executed the task. And that required it to call with a prompt. The prompt spurred some tool usage. The tool usage got some data back from the tool. It then took that information and decided that it was going to run again, get some more data with a second tool use, and then it returned the final output with the data that it received from its search of the web. Then the report writer executed. You can see the task creation, and you can see the report writer takes all of this information that it just got, and it generates a final answer, which is the report that we asked for. That is all there is to cover in this video. In the next video, we are going to take this set of traces and run actual evaluations on them.